Yeah. Now we will have a quick look about the numerical problems in three-phase induction motors. As already I told you, I'll be asking you very simple problems and particularly on determination of the slip speeds. So let's have a quick look about the formula. Synchronous speed is given by 120 f by p, and your slip speed is given by ns minus nr, and your percentage slip is given by the slip speed by synchronous speed into 100. Okay, now let's have a quick look about the problems. In the first one, see here, determine the slip of 4-pole induction motor, which means that here P is 4. It is running at 1440 rpm, which is nothing but NR, and is operated by, we don't bother about the voltage when we are talking about the speeds, right? So this is your frequency. So determine the slip of induction motor running at 1440 rpm and operated by 415 volts 50 hertz supply. And what happens to the slip if the speed is decreased to 1350? So what has been given for us? Number of poles is 4, frequency is 50 hertz, and the rotor speed is given as 1440. So first of all, let us calculate the synchronous speeds. Synchronous speed, you know, the formula is 120 f by p, where f is 50 and p is 4. So if you calculate, you will get 1500 rpm. Now this is here synchronous speed. What is the rotor speed? 1440. The difference between these two is called as here slip speed, right? So what is the slip speed? 1500 minus 1440. It is 60 rpm. Okay. So now when you want to slip, the slip speed by synchronous speed, it is 1500 minus 1440. 60 by 1500. You will get 0.04. If you want it as a percentage, you do it multiplied with 100. You will get 4%. Okay. Now they are asking you again, what happens to the slip if the speed is decreased to 1350? If it is decreased to 1350, then what is slip speed then? It is 1500 minus 1350. It is 150 rpm. What is a percentage slip then? 150 by 1500 into 10. How much it is? It is 10%. See, what is it? If the speed is decreased to 1500 rpm, the same problem. Decrease it to 1500 rpm. What is the thing? 10% is the slip. Okay. So now let's see. Determine the operating speed of the three-phase induction motor, where it is having 6 poles and a slip of 5%. Now slip is directly given, and they are asking you to determine the operating speed, which is NR. You know, the synchronous speeds can be calculated using 120 f by p. Frequency is given as 50 hertz, and the number of poles is 6. So 120 into f by p, if you substitute, you will get 1000 rpm. Okay. Now for the percentage slip, they are already giving it. How much they are giving? They are giving it as 5. The formula is ns minus nr by ns into 100. You know its value is 5. Ns is 1000, and you need to find out NR. To solve this one, you will get the speed of the rotor as 950 rpm. Okay. So I hope that now you are well acquainted with the three-phase induction motor. So they are widely used AC motors for producing mechanical power in industrial applications. Almost 80% of the motors, they are induction motors, and they are asynchronous motors, and they never run at synchronous speeds. And what is the formula for the synchronous speed? It is 120 f by p, and the difference between synchronous speed and the actual speed is called as slip speed, and the ratio of slip speeds to the synchronous speed is called as slip. Okay, so you watch this video. It will be helpful for you. It explains to you how the induction motor actually works. Okay, and I hope that now you are able to describe the construction, types of induction motors, principle of operation, and also list the applications, and also calculate the slip. I hope you are now able to calculate the slip of induction motor also. So this is my question. Question number 1. Why are three-phase induction motors preferred over single-phase induction motors for industrial applications? Number one, they can provide you with high power and they are self-starting. Yes, you turn on the supply, 3-phase AC supply, it will start moving automatically, provided the rotor is short circuited. If it is a squirrel cage, already short circuited. If it is slippery, you should short circuit. Now list any 2 industrial applications of 3-phase induction motors. You can have plenty of them, right? And also describe the principle of operation along with a neat sketch depicting the parts of 3-phase induction motor. As already I shown you, stator core, stator frame, stator winding, rotor, and of 2 types. You search on the internet a good picture of 3-phase induction motor, and you should be able to draw it in the examination. And see, one more question for you. A 415 volts 50 Hz 8-pole induction motor is running at 600 rpm, and you should determine the following: synchronous speeds, slip speed, and the slip. So if it is 50 Hz and 8-pole machine, what is synchronous speed? 120 into 8 by 50, right? So how much it is? You will get around 120 F5P, right? And it's my mistake, okay? 120 8 ones are 8 15s, right? So it is 750 rpm. Synchronous speed is 750 rpm. And what is the slip speed? 750 minus the machine is running at 600, right? So 150 rpm is the slip speed. And what is the slip? Slip speed by the synchronous speeds. What is it? It is 0.02. And if you want it percentage, you should multiply it with 100. So this is 0.2, right? 0.2. So it is 20%. This is how you will be solving problems. Okay. So I hope you practice some more problems at home. I have uploaded them in the course web, and in the class we'll have a quick discussion on 3-phase induction motor applications. Thank you.